Okay, good morning, all of you. Today I am going to give some idea on the gear tooth profile. Okay. So, why gear is needed? Because we all know mechanical drives, about mechanical drives. A mechanical drive is defined as a mechanism which intended to transmit mechanical power over a certain distance, usually involving change in speed or torque. Now, based on the mechanism, there are two types of mechanical drives are there. One type which runs on the laws of frictions, another with direct contact. So the mechanical drives are classified into two groups according to their principle of operations. The first one is the mechanical drives that transmit the power by means of friction. By means of friction, those are examples of belt drive and rope drive. And those mechanical transmission which takes place by means of engagement of the machine elements, those are called chain drives and gear drives. Now these gear drives, today our main emphasis is given on gear drives. Now these gear drives require the idea of basic gear. Now you can see this is the image of a spar gear, basic spar gear, and this is the animated view, a spar gear, how the motion is transmitted through the spar gears. You know, there is a central gear of yellow color and three peripheral gears. These are called the planet gears. The center one is called the sun gear, and these are the planet gears. If I rotate the sun gear, that is the central gear, as a result of motion, the planetary gears and this ring, the blue color ring gears, will rotate automatically. That means it will be transmitting power from the central shaft to the outer periphery. That is the transmission of motion, or we can say transmission of torque by means of this gear mechanism. Now, before learning to the gear mechanism, we need to know the different terminology of a gear. Now, those are basically, there are different terminologies related with the gear. The addendum, dedendum, okay, backlash, phase width. There are different terminologies are here. Now, today our emphasis will be on the gear tooth profile. The tooth profile. Tooth profile means this curve on the gear. That is known as tooth profile. Whether this curve is an arbitrary curve or of a certain geometrical shape, that is the question. And this curve is very much important in the design of gear. So before learning to the tooth profile, that means about this curve tooth surface, we need to know about the four basic imaginary circles that are related to the gear. The first one, P, if I connect all the top surface of the tooth by means of a circle, we can get one largest circle that is known as addendum circle. That is known as addendum circle. The next one is passing below the addendum circle. That is passing from below the addendum circle. This one is known as pitch circle. This one is known as pitch circle. What is pitch circle? Suppose there is a one gear and there is another pinion. Pinion is a small gear and gear is the larger one. So they both have some tooths. So this larger gear has a tooth like that way, like that way. And the pinion also have some tooth. So the pitch circle is that imaginary circle where we can say the tooth of the gear and the tooth of the pinion touches each other. That point is known as the pitch point, and the circle passing through the point is known as pitch circle. So pitch circle passes below, that means the diameter of the pitch circle is smaller than the addendum circle. The third circle is known as the base circle. That base circle passes from the bottom of the pitch circle. That is the base circle. The third circle is the base circle. So what is the principle of the base circle? Base circle is that circle up to which the profile of the tooth becomes a certain geometrical shape. At the above of the base circle, the curve is a certain geometrical shape, but below the base circle, the curve is not a certain geometrical shape. It can be any arbitrary shape. So the tooth profile belongs from the top of the tooth to the base circle. That portion is a certain geometrical shape, and it comes up to a base circle. Now there is another significance of the base circle. I will tell you later on. The fourth circle, the root circle, or it called the dedender circle. It is the smallest imaginary circle where the tooth ends. That is known as the dedender circle. So we need to know about these four circles. The largest circle is the addendum circle. That passes through the top of the tooth. The next one is the pitch circle. It is the imaginary circle where the tooth of gear and tooth of pinion touches each other. The third one is the base circle. The significance of base circle is the tooth profile belongs up to the base circle from the top of the tooth. And the fourth one is the dedender circle that indicates the bottom of the tooth, that means the root of the tooth. Okay, so these four circles are pretty much needed. Now tooth profiles. As we are discussing about the tooth profiles, I told you this is the curve by which the tooth is made of. This is the curve by which the tooth is made of. Now this curve cannot have any arbitrary shape. It should have some geometrical shape. It must have some geometrical shape. What are those shapes? One tooth profile can be cycloidal tooth profile. Another profile can be involute tooth profile. One is cycloidal, that means this curve may be either cycloidal curve or maybe a involute curve based on the application. Now first, let me tell you what is cycloids. Okay. Now there is a horizontal line. You can see there is a horizontal line on the floor, and if I rotate a circle on that floor, rotate, not sleep. If I rotate the circle on that floor, one point lies on the circumference of the circle. We trace a path. You can see this point, the point which is lying on the circumference of the circle is tracing a path, and that path is known as cycloid. This curve is known as cycloid. This curve is known as cycloid. Now, when the path is straight, it is known as cycloid. Now, we can rotate one small circle over a larger circle. This is the larger circle. The blue one is the larger circle, and the black circle, which is smaller than the larger circle, is rotating through the circumference of the circle. That curve is known as epicycloid. That curve is known as epicycloid. Okay, that red curve which is generating due to the rotation of the smaller circle over the larger circle, that red curve is known as epicycloid. There may be another cycloid that is known as hypocycloid. If the smaller circle rotates inside the larger circle, then one point on the circumference of the smaller circle will be tracing a path. So what did I say? So if the smaller circle rotates inside the larger circle, a point on the circumference of the smaller circle will trace a path, and that path is known as hypocycloid. That path is known as hypocycloid. Now, gear tooth profiles are generated based on this epicycloid and based on this hypocycloid. So these two curves are needed, epicycloid and hypocycloids are needed to generate the full profile of a cycloidal gear tooth profile. How will do that? So in that case, we can consider this is the pitch circle of the blue one is the pitch circle of the gear. The blue one is the pitch circle of the gear. On that pitch circle, we have placed a small circle. We have placed a small circle. Now I am rotating this circle in the clockwise direction. So what will it generate? It will generate a curve like that. Just we have seen an epicycloid. It will generate a curve like that way. It will generate some epicycloid. Now if I place the circle inside the bigger circle, and if I rotate this circle in that direction, so it will generate a hypocycloid inside the circle, bigger circle, pitch circle. In the same way, in that side, we have placed another circle, smaller circle, like that way. And if I rotate this circle in that direction, over the circumference of the larger circle, it will generate a curve like that way. That is the epicycloid. And in the same way, if I put the circle inside this pitch circle, and if I rotate the smaller circle in that direction, it will generate a hypocycloid like that. Now, how to get the final tooth? We can get the final tooth from this section. From this section. Now, how long this curve will remain cycloid? As I told you, so this is the base circle. This is the base circle. Now the tooth will remain cycloid from this portion to this green one, and below that it may not be cycloid, and it will proceed to the another tooth, the left hand side in the right hand side. So this is the tooth profile, cycloidal tooth profile. This is the cycloidal tooth profile. So a cycloidal tooth profile basically consists of four curves, two epicycloids on the top of the pitch circle and two hypocycloid bottom of the pitch circle. Okay, it consists four curves. So in that way we can generate cycloidal tooth profile. Now the second one is involute tooth profile. What is involute? For that you can see the animation here. So for that you can see the animation here. So in the involute tooth profile, you can see what is an involute of a circle. So there is a cylinder, and if I wrap a thread on the cylinder, and during unwrapping, the free end of the thread will trace a path. The free end of the thread, the path traced by the free end of the thread is known as the involute of a circle. So in that case, what we can do here, so this is the pitch circle, this one is the pitch circle, I can show you this one is the pitch circle, okay, and this one is the base circle, this one is the base circle. Okay, we can see this is the base circle. and this one is the pitch circle. Now from where we will start the involute? We will start the involute from the base circle. We will start drawing the involute from the base circle. Now think that we have wrapped a thread over the base circle. There is a drum of diameter of the base circle and we have wrapped a thread over the base circle and we are unwrapping the thread, keeping it straight. The free end of the thread will gradually will be increasing like that way. Okay, so if I join these points, we can get one involute curve. So from the other side, if we started unwrapping the thread from the base circle, the free end of the threads will be looking like that. So if I join these, we can get another involute curve in that way. So these two black curves are the involute curves, involute of a circle. Involute of a circle. Now the final curve will be like that. So that is a tooth profile for involute of a circle. And this curve will remain up to base circle. Okay. So that is the involute tooth profile. There is the dedendum circle. Tooth will be coming up to dedendum circle and this will be like that. This one is the involute tooth profile. So in case of involute tooth profile, we can see there are two curves. One is left hand side involute, another is right hand side involute. Now during meshing of two gears, so if it is a cycloidal tooth profile, so much more vibration occurs in case of cycloidal tooth profile compared to the involute tooth profile. Why? Because as I told you, if I go to the previous slide, as I told you, there are total 4 curves. The above the pitch circle, that is epicycloid, below the pitch circle, that is hypocycloid. Now when one tooth of the pinion meets with the tooth of the gear, it is sliding over here, that means it is keep touching over the surfaces. So it is there the upper one, when the tooth of the gear or pinion is coming in contact with the upper portion of the tooth, that means it is making contact with the epicycloid profile, and when it comes below the pitch circle, this portion, there will be a contact between the hypocycloid profile. So there is a changing over taking place from the epicycloidal profile to the hypocycloidal profile. That's why some vibration occurs. Okay. But in case of this involute profile, the total curve is involute. The total curve is involute, and whenever meshing occurs, so the tooth of the pinion or the gear is touching to a single curve profile, that is involute profile. So that's why in the involute profile, much less vibration occurs compared to the cycloidal tooth profile. Now, what is the importance of this base circle? As I told you, suppose there is a, this one is the pitch circle of a gear and this one is the pitch circle of the pinion. This one is the pitch circle of the pinion. Now the base circle of the gear is like that way. This one is the base circle of the gear, and okay, let me remove this one first. Let me draw it again. Like that way. and the base circle of the pinion is passing like that. If I draw a common tangent, if I draw a common tangent to the pitch circle of the gear, okay, let me give the name of the circles. So this is pitch circle of gear, and this one is the pitch circle of pinion, and these black circles are the base circles. Base circles. Now, if I draw a common tangent, if I draw a common tangent to the base circle of pinion and the base circle of the gear and passing through the pitch point, this point is known as pitch. And if I draw the common tangent to the pitch circles, if I draw a common tangent to the pitch circles, that line is known as pitch line. Pitch line. Now this common tangent to the base circle of pinion and the base circle of the gear, that line is called the pressure line. That means whenever a gear will be moving in this direction and the pinion will be moving in this direction, so tooth of the gear is giving a pressure over the tooth of the pinion so that it can rotate. So the direction of force which will be applied by the gear on the pinion is in that direction along the pressure line. And the angle between the pressure line and the pitch line, that is known as pressure angle. That is known as pressure angle. Now, how much pressure angle is allowed? The pressure angle theta, it can be either 20 degree or 14.5 degree. These are standard values. Okay, these are standard values. You can find any gear all over the world, the pressure angle will be either 20 degree or 14.5 degree. So these are the standard value of the pressure angles. So that is the pressure angle. So what was our aim for this class? Due to the short time, I have discussed only about the tooth profile of a gear and the importance of base circle and how the pressure line and pressure angle are related to the base circle. That we have done. Okay. So I hope you have understood well. Thank you very much.